Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 1, Section 2, Chapter 3, Topic 2. Ohm's and Kirchhoff's Laws, Part 2. Kirchhoff's Laws. Kirchhoff's laws, named after the German physicist Gustav Kirchhoff, are two fundamental principles used to analyze electrical circuits: Kirchhoff's current law, KCL, and Kirchhoff's voltage law, KVL. 1. Kirchhoff's current law, KCL. Kirchhoff's current law states that the algebraic sum of currents entering and leaving a junction, or node, in an electrical circuit is zero. In other words, the total current flowing into a node must equal the total current flowing out of the node. Mathematically, KCL can be expressed as n array summation n equals U, where n array summation n is the sum of currents entering the node. N array summation U is the sum of currents leaving the node. Key points of Kirchhoff's current law. Conservation of charge. KCL is based on the principle of charge conservation, which states that charge cannot be created or destroyed within an electrical circuit. Therefore, the total current entering a node must equal the total current leaving the node. Node analysis. KCL is commonly used in nodal analysis, a technique for solving electrical circuits by analyzing the voltage at each node and applying KCL to determine the currents flowing through the branches. 2. Kirchhoff's voltage law, KVL. Kirchhoff's voltage law states that the sum of the voltages around any closed loop, or mesh, in an electrical circuit is zero. In other words, the algebraic sum of voltage rises and drops around a closed loop equals zero. Mathematically, KVL can be expressed as n array summation loop equals zero, where n array summation loop is the sum of voltage rises and drops around the closed loop. Key points of Kirchhoff's voltage law. Energy conservation. KVL is based on the principle of energy conservation, which states that the total energy in a closed system remains constant over time. Therefore, the sum of voltage rises and drops around a closed loop must equal zero. Loop analysis. KVL is commonly used in loop analysis, a technique for solving electrical circuits by applying KVL to closed loops and determining the voltages across the circuit elements. Applications of Kirchhoff's laws. Analysis of complex electrical circuits with multiple branches and loops. Calculation of node voltages and branch currents in circuit analysis. Design and optimization of electrical networks for various applications, such as power distribution, signal processing, and control systems. Significance of Ohm's and Kirchhoff's laws. Ohm's and Kirchhoff's laws are fundamental principles that form the basis of electrical circuit analysis and design. They provide engineers with essential tools for predicting and controlling the behavior of electrical circuits, enabling the development of reliable and efficient electronic systems. By applying Ohm's law to determine voltage, current, and resistance relationships in circuits and using Kirchhoff's laws to analyze complex networks, engineers can solve a wide range of electrical engineering problems and optimize circuit performance. Conclusion. In conclusion, Ohm's and Kirchhoff's laws are fundamental principles in electrical engineering that govern the behavior of electrical circuits. Ohm's law establishes the relationship between voltage, current, and resistance in a conductor, while Kirchhoff's laws provide principles for analyzing currents and voltages in complex electrical networks. Understanding and applying these laws are essential skills for engineers and technicians involved in circuit design, analysis, and troubleshooting, as they provide a systematic approach to solving electrical engineering problems and designing efficient electronic systems. Whether designing simple circuits or analyzing complex networks, Ohm's and Kirchhoff's laws serve as indispensable tools for electrical engineers in various fields, including telecommunications, power systems, electronics, and automation.